I'm here to talk to you about breaking down monoliths. First, I want to say there's nothing inherently wrong with a monolithic app. If it's well designed and maintained, there might not be a good reason to change. However, given how things work here in the real world, this usually just isn't the case. I don't know your story, but I can make some guesses that I hope resonate, because I've been there. Almost everyone I've worked with has been a conscientious engineer, but sometimes their constraints cause them to make choices that cause problems for someone else, or that they themselves have to deal with later. It can come from something as innocuous as adding a feature to an existing app without taking a long-term view of things. I'll just add this here. And after that happens a few times, inertia starts to take over. Before you know it, you have a nest of dependencies that's hard to manage. Or maybe your app has become brittle. It's become difficult to make any changes at all. Hi, I'm Waldo. I'm a tech evangelist for Datadog. And this usually means that I get to travel and meet people, but regardless, I still get to advocate on your behalf back to my company. I'm a recovering ops engineer, and I've been active in the DevOps community for some time. I also enjoy sampling various projects, sampling various beverages, and collecting hobbies that I don't really have the time to get truly exceptional at. But while I'm not terribly interesting, my company is. Datadog is a SaaS-based monitoring and observability platform. We have over 400 integrations covering all of the most common applications and cloud services, and we ingest tens of trillions of data points every day. And as you might imagine, this leads to quite a few interesting problems. Now, perhaps unfortunately, there's no definitive definition of what a microservice is. This has caused some quibbling about what makes a microservice, especially around the idea of size. At its core, however, a microservice is really just an extension of the service-oriented architecture idea. There are a few properties that are often associated with microservices. First, they're generally abstracted, and this means that you can use a service without having a detailed knowledge of its internals. Another way to say this is that an application is API-driven. You really only care about the inputs and outputs of the service. Being reusable means that another service that needs the same kind of work can use it as well. By autonomous, I mean that it contains its own logic. Like it's not just a wrapper for something else. Also, the service doesn't need to be deployed in lockstep with other applications. Stateless means that an app doesn't persist state from previous requests within itself. This implies that it either returns all results to the requesting service or persists the data externally, such as to files or a database. Discoverability means that other services can find it in a registry. And finally, you can combine this service with others to assemble a larger, more feature-filled application. Now, I have to reiterate that this is not a hard and fast set of characteristics. It's more a set of properties that are especially common to microservices. And now that I've described some common properties of them, you might be asking why you'd want those qualities, or why you'd want to write your applications in such a manner. There are actually quite a few reasons, and they're not all hype. Microservices allow us to keep our architecture loosely coupled. This allows you to deploy individual components when they're ready in small incremental batches. It also allows you to make smaller experiments that are easily swapped into and out of use. When your product components can be built, tested, and deployed in smaller pieces independent of one another, you experience a much faster velocity and agility. Faults may be resolved more quickly, and experiments just by themselves are less risky. With a faster feedback cycle, your engineers are less likely to fall out of their mental context when a change is needed. Again, with small components, you can go from idea to production much more quickly and cheaply. And with that, the feedback is much more available much sooner. Simple fact, small applications deploy more quickly. When you have a scaling event, it takes less time for new instances to be created, whether you're deploying containers, server images, or code directly to longer-lived servers. Additionally, by keeping your apps small, you can deploy more servers in a size-appropriate manner. This means that you can increase capacity by smaller increments and not have to wait until you're at a limit before adding additional servers. Because your apps deploy more quickly, deployments and scaling events can also be set to be more responsive. So this means you don't have to worry about leaving yourself enough time to deploy if you have to scale or replace failed instances. When you deploy an app in an SOA, implementation details don't matter to other services. Nobody cares that you're a Java shop or you really love Python or Node or whatever. This happens because you published an API. As long as the inputs and outputs don't change for the requester, what happens behind your interface is nobody's business but yours. Finally, cloud providers seem to be best at hosting lots of small things. They're generally not as good with large ones, and besides, large instances come with very large costs. Sooner than later, you're going to have to figure out what new apps you're going to be making as you peel components out from your monolith. How you do this will vary widely depending on many factors, such as the engineering talent you have on hand and how messy your monolith is. Various parts of your monolith probably already have nouns and verbs associated with them. Thinking those individual sections as separate nouns and verbs is a relatively simple way to begin identifying products to spin off into new services. There are two very real pitfalls that you need to be aware of: analysis paralysis and definition arguments. Obsessing over the right size to make your split off apps can be a huge time sink. It's more important to begin the process of splitting off new services. Besides, arguing over the sizing is silly and can turn into a huge bike-sheddy time sink if you let it. If you find that your new service is larger than you like, making a mid-size SOA type service into two smaller services later on is much easier than splitting it from the monolith in the first place. One method that I've learned for identifying components comes from Sandy Metz and her philosophy of writing small things. What I've learned from her is to ask the thing that you're inspecting, whether it's a service, a method, or an object, what it is or what it does. When that component responds to you, if its answer includes the word "and," you don't have one thing, you have two. There's nothing saying you have to use this method, but I find that this is something that has worked for me. As exciting as this work can be, and I know you just want to dive in, you're going to have to do some due diligence up front. You want to take some time to sharpen your axe, find your gloves, and do some stretches. First, you want to identify your current components and how they're currently referenced. I encourage you to create a dashboard that shows each application endpoint from both the monolith and the new services, so you can visualize your team's successes in migrating requests. Such a dashboard will also help you hunt down components that really just aren't used anymore. Using the components and interactions, you'll want to make sure that your code is written and properly tested automatically in your CI, and that your application's functionality is properly monitored in production. The service contract includes an intention of problems that the service will solve. Also, things like the expected load, error budgets that you're writing to, and guidelines for the API reference. Now, this may seem like unnecessary paperwork, but ultimately it is important for your quality of life. Describing the functional parameters that you prepare and test your application against will help set expectations. Should you suddenly find that your application is falling over when, say, traffic surges unexpectedly, it doesn't absolve you of your need to be available, of your app's ability to run, but you can at least describe the load that you tested for. Now that you are fundamentally changing how your applications operate, you need to make sure that the results are the same as before. This ties in directly to the red-green refactor of paired programming, because that's exactly what you're doing. You're doing a huge refactor. Since you're thinking about testing, it's also a good time to make sure that your monitoring relates to the important tests. But now you're finally ready to get to work. It's time to break off your first chunk. I recommend that you start with a peripheral service. This doesn't necessarily mean a particular category of application, but rather look at components that don't rely on core business logic or heavy interaction with other services. For your first services to peel off, you might want to look for easy wins that help build new habits and help teach lessons with lower stakes. It's at this point that I want you to consider how you want to manage your application routing. This is something that you'll need to solve, and ideally that's something that can be toggled pretty much live in real time. If you find that your shiny new service is missing something vital, you want to quickly roll back behavior without having to redeploy or restart a fleet. And this could be as simple as choosing what kind of application routing you want to do. If you're in Kubernetes, whether they're deploying services, if you're using reverse proxies like Nginx, or using something like the name escapes me. You can do this at many different layers, but being able to quickly configure how your applications route is really helpful in this process. Getting this right is going to be vital in the long run, but it's also important to remember that you can iterate on this over time. And as you go, you're going to find that you'll come to a point where you aren't sure which thread you're going to tug from your monolithic sweater, as it were. As new services are pulled out of the monolith, you're probably going to need to continue updating the services that have already been extracted. And this is where that dashboard I mentioned earlier comes in handy. Using your logging and dashboards will also help you hunt down components that are still using the old instance. And it's also a great reminder to celebrate your successes. Now, remember, there is no strict definition of microservices. Humans like to categorize and define, but nature and software can be messy. If you have highly dependent components, it might make more sense to leave them as macroservices for now, and that's okay. A few larger services are generally still going to be easier to run and scale than a monolith. Again, this is something that you can iterate on, and you'll get better at it as you go. If there's one guiding principle, I would recommend that you optimize for team velocity, second only to the customer experience. Additionally, it bears keeping in mind that different teams may choose different optimizations. That too is okay. Potentially more disruptive, but I think vital for your long-term sustainability, is the move to product-oriented teams. A product team is a largely self-contained team that's tasked with solving problems. The team is largely self-contained, meaning that they create and run their own solutions, and autonomous, meaning that it's largely up to them how they solve their problems. Product teams are the polar opposite of what is referred to as the studio model of funding, where a team will work on consecutive projects. This name largely comes from the film industry. But in general, studio model funding based on projects works well for products that aren't run as a service, such as like mobile apps or games that don't have an online component. It works really well for films that are created, published, and put out into the world. But in the product team model, it's the team itself that is funded, and it's tasked, again, with solving a set of problems which they implement and they run long term. Now, if team funding models doesn't make sense to you, please enjoy that you've lived a blessed career. In my experience, the studio model is a leaning into the idea of throwing code over the wall for somebody else to deal with. And it's a really fantastic way of turning out legacy code. Now, this is in contrast to the self-contained product team that runs its own solutions, which honestly I consider to be the definitive implementation of doing DevOps well. Now, chartering your product teams, this doesn't have to be a huge, complicated document. Its main purpose is to establish a specific set of problems that the product team is responsible for solving, and a manifest of people or roles who will be dedicated to the solving of this problem. And this too is something that can be experimented with and iterated on over time. But for now, give a team a problem to solve and get out of their way. Now, in my time with you today, we've talked about what benefits you may seek to gain by splitting a monolithic application up, the due diligence and planning that you should do before you initiate a new Git repo and start writing your new microservice, and how to think about the new services in terms of the new applications and the teams that will service them. And with that, I thank you for your time. I hope this was helpful and informative, or at least entertaining, and I'll take questions from the chat. Let's see. Do we have any questions? Let's see. Okay, from George Guja, I hope. Do you have any examples of what would be a good first area to break down into a monolith? Break down from a monolith, like the logging service. I think that's a good idea. So login service is something that is definitely a discrete service that you have a name for. It has a core set of functionality, and it probably doesn't rely on a bunch of other things, but I would honestly recommend against doing something like that as one of your first services, strictly because it is a very it's a very important service. It's obviously going to have, in general, a lot of use. So it's kind of high risk. And if it goes poorly, like I've seen teams or executive or levels of leadership get a distaste for that kind of thing if it doesn't go well right off the bat. So that is one that I would leave for later once you've developed some practices around splitting services off into off of monoliths. But if you have, that you have a service that you can name, that is a good start to things. Let's see, from Ekta Agarwal. Again, apologies for any pronunciations here. What is the best way to manage versioning across microservices? This is going to be this is a topic that can, again, have a lot of arguments and bike shitty discussions, but you're sticking to a standard. And I mean, but by default, as far as versioning applications, I'm going to default to Semver personally, but having multiple versions of your applications running is a fine idea, as long as you keep them published, but also having some shorthands for current or stable or experimental for, if you have customers who are using your APIs and don't necessarily keep, it depends on how open about things you are and how you maintain your documentation as well. Having the versions as part of your path with aliases that change between different published versions is one way to go about that. Again, that's a huge topic all by itself. But I hope that helps, Ekta. Let's see. Shahraz Bari asks, are there integrations with Datadog and Azure? I can say yes. While this talk isn't, I am an evangelist for Datadog. This talk isn't specifically about Datadog, but yes, we do have a whole mess of integrations, and we are continuing to write more with Azure. And we do a lot of launch partnerships with them. If you want that information, you can go to datadoghq.com/integrations, and they are all right there. So another question from Ekta. Once a monolith is broken down, we have the n number of services, the contracts across which have to be monitored and managed. Are there any tools or practices that you recommend for this? So as far as monitoring, I can give you one recommendation, but it might seem a little self-serving. But yes, I can recommend different monitoring services. As far as the contracts go, the idea here is this ties into a number of things, part of which is going to be just documentation that is inter-team, like describing what the team does, the kinds of things that you like load test for and anticipate, and even your test cases, your CI testing. It's not a bad idea to describe the broad test cases that you test your software for and expose to your partner teams. It's not necessarily something that you might want to make public. It depends on the nature of your company, really. But as far as the promises that you give, SLOs, so service level objectives, this is a fantastic tool and resource that's widely known within the DevOps and SRE communities that allow you to, and of course, Datadog has widgets and stuff to help you expose this. You can publish what your SLOs are, describe the availability that you're promising to your other teams, and you can use these tools. You can use your current status and however much error budget you've used versus how much you have remaining to determine whether you're going to prioritize feature development versus stability engineering over, whether it's today or during this week or the sprint or whatnot. I hope that answers your question. Let's see, Scott. Thank you for the compliments. I appreciate it, and yeah, I'm glad people seem to have enjoyed it. And does moving into, let's see, from Salvatore, does moving into a microservice architecture, we're scrolling a bit, necessarily mean that the company needs to move into multiple backend teams handling different services? Salvatore, the answer to your question is no. By moving from more monolithic apps to smaller service-oriented apps, you do not have to change how your company is structured. It is absolutely not required. However, I think that in general, that running as product teams, that everybody has core things that they care about, not only the solutions that they provide, but also their operation ability. I think there is a fantastic feedback loop that happens, especially for software engineers who aren't necessarily used to being on call for and responsible for their applications. I think it is wildly beneficial for them to be the primary on call for their applications. There's a whole nother talk, but I think that being on the hook for how well a service runs incentivizes people to write their services with resilience in mind. And it's not that they don't care about it otherwise, unless they are on call for it. That's not the case. They're just not incentivized to care. So other things can take priority. And likewise, having, you can have one large pool of engineers, but then I think that when you have a lot of people who could potentially jump on something, or be responsible for something, there is a tendency to assume that somebody else is going to take care of it, or that roles unofficially come up. Well, this person always takes care of the cart service. This person always takes care of the ID service. And if they're not there, those things might slip down the cracks, like if they're out for the day or if they're busy with something else. I hope that answers your, like the short version, Salvatore, is no, you absolutely do not need to change your staffing models. But I think it's a good idea and a good opportunity to, when you're migrating from larger applications to more smaller applications. Let's see. All right, some congratulations and thanks. Again, thank you very much, everybody, for coming. I hope this was helpful. I'll stick around for a little bit, but I think that the next session is starting up in 3 minutes. So with that, I hope everybody has a great day and enjoy the sessions here at Destination Scale. Take care, folks. I'm G Waldo on Twitter. If you want to reach out, if you have other questions, happy to help. And I look forward to seeing some people in this coming year. Lars, absolutely not. Nobody needs to hear me. I will ruin all the goodwill that I've built up over these last 38 minutes. All right, folks, take care, and I hope to see you at events soon.